The square root property. A quadratic equation of the form x squared equals k can also be solved by factoring. So if we take a look at the first part, if we subtract k to both sides and set it equal to 0, we would get x squared minus k equals 0. Now we want to be able to factor this using the difference of squares. So if you recall that the square root of k times the square root of k is the same thing as the square root of k squared. And then what that equals is, what do you have to square to get k squared? Well, that equals k. So that means that we can factor this by using the square root of k and the square root of k. So you can see here that we're factoring this by turning this into x squared minus square root of k times x minus the square root of k times x plus the square root of k, and that's equal to 0. So we factored this into this form. Now again, we're using the 0 factor property right now, and so now we can set both of these to equal to 0. So we would say that x minus square root of k is equal to 0, or x plus the square root of k is equal to 0. And then we're going to add square root of k to that side, and then we're going to subtract the square root of k to that side. So then what we end up with is the following. We get the following solution. We get x, which is equal to the square root of k, or x is equal to the negative square root of k. So what does that tell us? Well, that tells us that if x squared equals k, then we automatically know that x is going to equal the square root of k, or x is equal to negative square root of k. Now, another way that we can write this in a simplified form is the following. So we can either write them in two different solutions. We're going to have this negative square root of k, square root of k, or we can write this in a simplified form where this is plus or minus the square root of k. So this is what we would do in terms of using the 0 factor property. Okay? But now we want to look at another particular property. So we're going to use, again, the square root property. So in this case here, the solution set of x squared equals k, we wrote as the square root of k comma negative square root of k. You usually write the smaller number first, but it doesn't matter which one you write first or second. But it's just kind of proper order when you think about the order line. And this also may be abbreviated, like I said in the previous example. This is plus or minus the square root of k, embracing braces. Okay. Now, both solutions are real if the value of k is greater than 0, meaning that the number that's underneath the radical sign is going to be positive. Because if this is an even index, it has to be a real number. Okay. And both are pure imaginary if the value of k is less than 0. So if this value under the radical is negative and it has an even index, then it's going to be an imaginary solution. Okay. Now, if k is less than 0, then we write the solution set as plus or minus I times the square root of k. So let's just take a look at a minor example here. So if I had the following, let's say if I had plus or minus the square root of, let's say, negative 5. Okay. Well, that means that k is less than 0. And if k is less than 0, then this is going to be in a pure imaginary number. So the best thing to do here is that we're going to rewrite this by factoring out the square root of negative 1 times the square root of 5. And what we know is that the imaginary number I is equal to the square root of negative 1. So therefore this becomes plus or minus I times the square root of 5, which would then be that result, which then looks like that. Okay. Okay, now if k equals 0, then there's only one distinct solution, 0, sometimes called a double solution. So that means that, let's say if we had plus or minus then the square root of 0. Well, that would give us 0 because 0 is neither negative nor positive. So therefore, we would have only one distinct solution at 0, but it could be called a double solution because we literally have a positive and negative there, but it's neither positive nor negative. So therefore, those are the types of solutions that we may run into.